We'll address two questions that are in review test number 3. The first question is number 1H, and the second one is 2A. Both of those questions relate to the function or the equation y is equal to the secant of the arctangent of x. Okay, first let's talk about question number 1H. It asks for the differential of the function. So we have y is equal to the secant of the arctangent of x. Now we have two functions, one acting on the other. That's a compound function of the nature of f of the g of x. And we know from class that to differentiate a compound function like that, we have to consider that we have an outside function and an inside function. If we want to take the differential of that, it's going to be first the differential of the outside function times the differential of the inside function. So now we apply that to our equation, and if we have the differential of y is equal to, first, this is going to be our outside function, and the arctangent will be the inside function. The differential of the secant of theta is the secant of theta times the tangent of theta. So first, differentiating the outside function, we will have the secant of the arctangent of x times the tangent of the arctangent of x. And so that gives us the differential of the outside function. Now we multiply that by the differential of the inside function. The differential of the arctangent of x is equal to 1 over 1 plus x squared. So that's our differential of the equation. Now we go to question number 2A, and that asks for an evaluation of the function. So we have the function y is equal to the secant of the arctangent of x. And we know that when we are trying to evaluate an inverse trigonometric function, we can let theta equal to the inverse trigonometric function. So it's going to be equal to arctangent and then if we take the tangent of theta, we get the result of the arctangent. So the tangent of theta is going to be equal to x. That's the same as x over 1, and you'll see in just a second why we express it that way. Let's now draw a right triangle. This is our right angle here. We'll let this angle be theta. Could be either one, but it doesn't make any difference. Then we have the three sides. We have a hypotenuse, we have a side opposite the angle, and we have a side adjacent to the angle. Now, we know that the tangent, in addition to being the tangent is going to be the opposite side over the adjacent side. So here it would be, well, let's do it. No, this will be the opposite side over the adjacent side. So this will give us an x here and a 1 here. We know that the hypotenuse is the square of the hypotenuse is the sum of the square of the other two sides. So the hypotenuse is the square root of the sum of the squares. So the hypotenuse would be the square root of x squared plus 1 squared, which is just 1. So now we have our right triangle, and we have our angle, and we have the three sides. So we can go back to evaluate. Y is now equal to the secant of theta. And we know that the secant of theta is going to be the adjacent side, the hypotenuse over the adjacent side. So here, it's the hypotenuse over the adjacent side. So y is equal to the secant of theta equals the square root of x squared plus 1 over 1, where y is equal to square root of x squared plus 1. And that's the evaluation of our equation. Thank you.